Hey, welcome everybody once again to Astronomy Daily Live. I just found this thing in my pocket and I don't I don't know how it got there. It's a little plastic thing. I don't know. Well, just another how'd that happen? I don't know. So hey, welcome everybody. Hope everybody's doing well out there in the universe and the world. Things are good here. As you can see behind me, there's no telescope except that one. That's because the telescope is outside waiting for it to get dark. It's supposed to be clearing up here, and there's a big cloud bank over us right now, and but everything's moving pretty rapidly over me right now, and looking at the satellite loop and looking outside, because I like to see things on the ground. I don't necessarily trust anything. And even that, my own eyes are like, they're only so good. So, but I'm looking out there, and I think it's going to be clearing up here pretty soon, in the next hour or so, hour and a half, something like that. So I think there is definitely going to be an observing session. Hey there, Tom. Nice to see you in the chat. Uncle Bill, nice to see you too. Great to have you here as usual. A couple of the regulars, very, very great to see you guys each and every day. So I think that's absolutely fantastic. So yeah, it should be clearing up here. Hey there, Chuck. Nice to see you too. Excellent. Yes. Cheers. Yeah, absolutely. So yeah, it looks like it's going to be clearing up here. So I basically have the same plan that I did the other night. So M65 in blue is definitely on the agenda once again, and I will, I need to stick to the protocol regardless of what is screaming in my head. It's like, nope, just stick to the protocol and things will actually work out better. So I need to do that. I've there's a cat smashing on the mouse. I have a sort of a personal Facebook account, which isn't incredibly active or anything. I don't think I've been over there for a long time. So no, and I don't know if I'm going to go that route or not. Yeah, that's a good thought. And I greatly appreciate the share, for sure. So that is spreading the word, and if people are so inclined, they will find a way. So if it isn't, if they have to go through YouTube instead of Facebook, if they think that is something that they can do, then they're going to go ahead and do it. So I think, yeah, for now I'm going to stick with the two that I've got. Three, really. I've got YouTube, Twitter, and Discord. Yeah, I think three is enough at this point. So yeah, that's where that is. Anyway, so M65 is definitely on the agenda with the blue filter. Now I need to take some better calibration data, but with the clouds, I'm not going to be able to get good data at sunset, and I mean, it's obviously past sunset now, so I still need to get some better blue calibration data, but I've got some, and from the other night, and hopefully the pointing with the telescope will be such that I will actually be able to find this stupid galaxy and get some more data on it, because I want to take the blue data and subtract the green from it, and I want to see what's left over. That is what astronomers call color, or the color index. So yeah, I'm kind of interested in seeing, especially with the galaxy, if I can notice color differences between like the center of the galaxy and the spiral arms, or different regions of the spiral arms. Now the signal to noise is pretty low, so the quality of the data isn't going to be great. But if I can see a difference, I'd call that pretty successful. So yeah, if I can see a difference in color between like the center and the spiral arms, then yeah, I think that'll be nice. So M65 is on the agenda. M1 is definitely on the agenda, and yeah, I figured that there probably was a color difference, and of course my question is, can I see it? So the only way to find that out is to collect some light in the green part of the spectrum, and collect some light over in the blue, and then I look at the differences and see what happens. If the redder the light, that means that the magnitude, that the brightness of the green filter is going to be greater than the brightness of that same region in the blue filter, which means that the blue minus green color index is going to be positive. So the B magnitude is going to be larger than the green magnitude, and that's because the magnitude scale in terms of brightness is reversed. So yeah, I'm hoping to see that. So M1 is a possibility. R Leo is definitely a possibility too. And I have another opportunity to watch yet another eclipse from HY Virginis. It's going to be doing its 20-minute eclipse starting at 4:22 UTC. So what I plan on doing there is just collecting data for an hour. I'm going to start at 4 hours UTC, and I'm going to go to 5 hours UTC, and just collect. I'll probably be doing like 3-second exposures, so I'll be able to collect one data point like every 7 seconds or so for an entire hour. So let's just see what that is. Of course, I've grabbed my handy dandy calculator, which is always within arm's reach. Every good scientist has a calculator now. Not a calculator on a computer, right? I'm talking about an actual one. Every good scientist has one of these. Some kind of scientific calculator. It doesn't have to be this. Can It can be an HP like that, which I still have to get some batteries for. Whatever. Anyway, so there's 3,600 seconds in an hour, and if I collect an image every 7 seconds, that's 3,600 divided by 7. I'll get about, wow, I'll get like over 500 images. So yeah, that'll work out just fine. I can sort of assume that probably 10% at least are going to be lost because of tracking. Having to correct the tracking, and that streaks the stars, and so I've got to throw out that data. So yeah, I'll be looking at that again as long as it clears up. So that's like I said, that's going on from 4:22 UTC to 4:42 UTC, the actual eclipse. That's what the expected time of the eclipse is. And like I said, I'll be watching it between 4 and 5 as long as it's clear. So yeah, that's sort of the plan there. And so actually what I'm probably going to do is keep this live stream maybe a little bit shorter than normal, because well, I can actually show you here what I'm about to look at. It's the share my screen, and hey, I don't know if anybody saw the note that Bobby left over on the Discord server, but he is having dinner with his family tonight, so he is not going to join us, but he is definitely well missed, and hope he enjoys himself. Hope he is enjoying himself. So this is the Observer's Almanac for the MMT Observatory, which is fairly near me. So this Observer's Almanac works well for my location. It's probably not going to work well for your location. so I'm just special because I'm surrounded by these observatories, and they publish this kind of information. So what we're looking at here is we can look for now it's still April 4th here. It's actually UT time is April 5th, but I've got to go by the actual date and hour here. And as you can see, sunset was at 6:45 p.m. and astronomical twilight ends at 8:08 p.m. So I definitely want to be out there. I probably need to get started around 8. So that gives us a good solid 45 minutes left. And it's really, really great. It's all I have to do is run outside. I don't have to go anywhere. It's awesome. I cannot tell you how many years I've dreamed of being able to do that. So if you've never heard actual proof of dreams coming true, I have proof that actually happens. Yes. I wish a few other dreams would come true, but that's for a different live stream. So, all right. So yeah, I've got until 8:08, and then that's when I want to be starting on data collection. And so yeah, I'll probably shoot for 65 first, M65 first, just because it beat me last time. The system beat me, and I just I need to it's the situation. It's extremely similar to falling off your bike, and what are you supposed to do? You're supposed to get right back on and ride it. Don't be like, man, I'm not going to ride that anymore. You just get right back on, no problem. So, you know, this thing beat me the other day. Well, yeah, get right back on, no problem, no problem at all. So what I wanted to do today, and what I like to do at the beginning of every month, and we're a little bit late here, is go over to cloudynights.com and take a look at their April celestial events. So these are just sort of you know things that happen in the sky over the course of the month, and they're oftentimes jumping off points, you know, for various topics and whatnot that we can chit chat about. So I'm gonna make sure that I'm keeping track of the chat. M1 is nice. Yeah, the problem that I've got with M1 and that scope is that the field of view that I have is so narrow. I need two relatively bright stars, and what I mean by that is I need like 11th, 12th magnitude stars. I cannot do what I have to do with 13th or 14th or 15th magnitude stars. I don't have enough to grab onto. So I need two relatively bright stars in each image so I can properly stack them. There might be other ways of doing that where I might only need one star. I'm thinking about that. That's still the concept, you know, the algorithm hasn't popped into my head yet. So at the moment, I need two stars to grab onto, and they can be anywhere. I don't care, but they need to be a high enough signal to noise. They need to be relatively bright. As I said, 11th or 12th I would say about 12th is about as faint as I can probably grab onto. So yeah, and with M1, there's one pretty bright star next to it, and that's about it. So yeah, I'm gonna try to increase my exposure times a little bit. You know, there is a fainter star. It's probably about 12th or 13th that I'm just not able, you know, to grab onto. So, but yeah, I definitely want to get a bunch of images of M1, and I want to do exactly the same thing, right? I want to look at the color index and see what's going on there, see if I can see, you know, some differences. I should. Anyway, so yeah, let's go over to Cloudy Nights. I'm gonna take a big gulp of this hydrogen hydroxide here. Cheers. Jim, no, I'm not. And you know, I have one. I have a 0.5 focal reducer, which of course would increase, you know, my field of view by actually a factor of 4 in area. And the problem that I encountered with that is that that has changed the back focus of the CCD camera, so I can no longer focus. So yeah, that's sort of been postponed. I actually got the focal reducer to widen, you know, the field of view a little bit, but unfortunately, I haven't felt it a priority to work on that. What usually there are at least a couple of stars in the field of view I can grab onto. So you know, this is part of what I'm doing, is trying to characterize what the limitations of my system are. And you know, one of the limitations at the moment is that if you want me to collect data on a target, that target has to have 2 bright stars within the field of view. And you know, it's not necessarily up to the you know, person who wants this data, you know, to tell me whether it is or not. I'm going to have to check that out and get back to them on, you know, if that object is going to be able to be observed. And M1 might be one of those objects that I'm just not going to be able to grab onto unless I come up with a different way of stacking, some kind of single star stacking where I have to deal with telescope tracking all over the place and also field rotation. And it's the field rotation that requires the 2 stars. If I just have 1 star, I can easily trace, you know, how the tracking is going, but I don't have any angular information there. So I need 2 stars to work out that angle. So once I can find those 2 stars, I can look and see how they've changed, and then I can make the rotation. But without 2 stars, I haven't figured out a way to do that with a single star or with 0 stars. Maybe there's a way to do that. I'm not exactly sure. I can't think of one, but I'm not too bright. So, you know, maybe there is something extremely obvious that I'm not realizing about that. So, still thinking about that. But yeah, a wider field of view would definitely solve that problem. And you know, wider field of view also means that I decrease my angular resolution. I'm not able to do astrometry quite as well. So, you know, there are trade-offs. So I think at the moment, and this is why it hasn't really been a priority. Do I have that? I think I've got it. I don't know where I've got it. Anyway, yeah, it's just not a priority at this point. So, okay, let's go over to Cloudy Nights and take a look and see what is going on this month in the 30th or 30 or so minutes left that we have here. We can do that. I'm not in really any hurry. If we're not able to get through the whole thing today, we'll try to get through the rest of it next time. We just have to sort of get started here. So okay, so I'm going to share my screen, like that. Go to infinity, down to the black hole, as Bobby says. Yeah, that's great. All right, so here's cloudynights.com, of course, and you know, this is a really great site. I say this every time, you know, we come over here. It's extremely active. It is definitely, you know, the amateur side of things. So, you know, if you're looking for, you know, any kind of sort of, you know, professional advice, this is the wrong place. But for everybody else, this is absolutely awesome. Extremely friendly, extremely knowledgeable people. These folks really know their stuff. So if you don't visit this site often, I think you should. Put it in your rotation. That's sort of what I do. I have a rotation of sites, you know, that I like to visit, you know, from time to time. So I definitely get in here when I can and take a look around, make some comments, answer some questions, you know, that kind of stuff. So anyway, so let's take a look. Now, of course, we've missed out on the events of the first 5 days of the month, but let's see. On the first, the moon was at the apogee. which is the furthest away it's going to be from the Earth this time around. And okay, so it happened early on the first at 0 hours 14. So there was a double Galilean shadow transit. So the Galilean moons of Jupiter, there are 4 of them. There's Io, there's Europa, there's Ganymede, and there's Callisto. And these are the 4 moons that Galileo saw through his telescope. And first human to ever see these things, as far as we know, at least. And was, I mean, it's hard to imagine what went through his head when he first looked and saw these points of light around Jupiter that were all lined up. I mean, it's if you haven't seen Jupiter through a telescope, that's one of the most striking things that you see right away. Because our brains want to find patterns, and lines are great patterns. And so our brain just locks onto those things right away. And so it's very, very striking. So I'm sure when he first looked at Jupiter and saw this line, I mean, the first thing he probably saw was that line of stars. And it's like, wow, that's an interesting coincidence. And then, of course, over time, he watched these things and they seem to move. They seem to be not different objects, but objects that were actually moving and orbiting Jupiter, which was, of course, unheard of at the time. So everything goes around the Earth. So pretty good. Anyway, from time to time, we can observe one or more of these moons and or their shadows transiting Jupiter, passing in front of Jupiter. And sometimes you get these doubles. So that's pretty cool. Let's see. Let's skip to today. Look at this. April 5th, new moon occurs at 8:50. So we're about 6 hours and 20 minutes away from new moon. Very nice. Asteroid Iris is at opposition, which means, of course, that it's on the opposite side of the sun. So it's about as close as it's going to get to us, and it rises when the sun sets. So I actually I was looking at this earlier and I noticed that, and it's like, well, maybe I should make some observations of Iris tonight too. But I think I'm going to keep this in mind, and maybe I'll make some observations at some point, because this again is part of the program to try to characterize my system and see how well I can measure the position of these moving. I mean, it's not a target, but a moving object, and see how my measurement compares to what the predicted orbit is. So yeah, I will definitely keep Iris in mind. It's bright, and it's up. It's up all night right now, because of course, as it rises, the sun is setting, and as it sets, the sun is rising. So it's up all night. All right, let's see what else is going on here. Tomorrow, the moon is relatively close to Uranus. That's not terribly exciting. Ceres is stationary which means it's just um, as it appears to us, it stops moving. So that's just to do with the dynamics of the orbits of the Earth and Ceres. Let's see. Okay, well, the moon is 8 degrees southeast of M45, so that's relatively close. That puts it pretty close to Mars too. I know that Mars is over there. Oh yeah, here on the 9th. On the 9th, it looks like the moon and Mars are going to be about as close to one another as they're going to get this time around. Asteroid Pallas is at opposition. Oh wow, okay, I didn't know that. I observed Pallas a couple weeks ago, and I definitely want to do that again. So it's kind of interesting that, and I mean, it's just a coincidence that Iris and Pallas are both at opposition. I mean, more or less on the same day. I mean, a few days apart. So yeah, I should probably continue to look at Pallas too. I haven't made any astrometric measurements of that data yet. That and Eros. I've got all that data to look at too. So I'm swimming in data at the moment. I just have to run it through a little bit. It's tedious work. So I know what's involved, and I'm just putting it off. So that happens at 1 hour UTC on the 10th. So just an hour before this live stream happens, we have opposition. Mercury, Venus, and Neptune lie within a circle with a diameter of 5.2 degrees. Okay. So Mercury's at its greatest western elongation on the 11th. So get up early in the morning and probably, let's see, that's the 11th. Today's the 4th. I would say, from now through the 18th, which is a week from, past greatest elongation. So I would say from now, like tomorrow morning, through the 18th is a good time to see Mercury, as long as you're willing to get up before sunrise. You've got to get up, an hour or so beforehand, and you will definitely see it over in the east. Let's see. So some lunar features that, because of the timing and the shadowing and all that kind of stuff, they look like various things, lunar X's, and there's a bunch of things up there. So the moon is at the ascending node at 1800 hours. What that means is that it is passing the celestial equator, a declination of 0 degrees, and it's heading north. Hence the name ascending. It's going up. It's moving north. Let's see. So first quarter moon is also on the 12th at 1906. That's kind of a cool shot. On the 13th, the moon is going to be in the Beehive cluster. So all you astrophotographers, that's going to be a great shot. Yeah. Look forward to seeing a few of those. I'm sure there will be. You should start Regulus, Mercury. So the moon is at perigee, which is its closest that it's going to get to the Earth, on the 16th at 22:05. So sort of late on the 16th there. So that is perigee. Okay, so Venus is at aphelion at 2 hours UTC. So right at the beginning of this live stream on the 18th, we'll have to try to remember to give a little shout out to Venus being as close to the sun as it's going to be in its year. 0.7282 astronomical units from the sun. So that's getting pretty warm. It's getting pretty close. Actually, the aphelion, I'm sorry, is the furthest away it's going to be. Yeah, silly me. Yeah, that's actually the furthest it's going to be away. So yeah, 0.7282. That's still really, really close, but apparently not as close as it can get at perihelion, which is when it's at its closest. And I don't remember the exact orbital period of Venus, but I want to say like 140 some days. So so what, we've got to wait a couple more months, and it'll be at perihelion. Yeah. Let's see. Going by Spica, the sun enters Aries at 11 hours UTC on the 19th. Full moon also takes place on the 19th at 11:12 UTC. Longitude 30 degrees. Okay, I'm not quite sure why that's so interesting. Yeah, not quite sure about that one. Okay, so Uranus is in conjunction with the sun at 23 hours UTC. Now Uranus, I think that we can see Uranus with the SOHO spacecraft. I think. So SOHO, of course, is looking at the sun, but it's got those two wide field, I think they're called LASCO instruments. They block the light of the sun, revealing the corona and the background sky. And so you know, even though we're looking at the sun, we can see some pretty faint objects behind it. And Uranus, it's as far away from the sun as it's going to get. I'm sorry, from the Earth as it's going to get. You know, it's on the opposite side of the sun. Hence, it's in conjunction with the sun. So it's probably about as faint as it's going to get as well. So yeah, I don't know if we'll be able to see that or not. So the Lyrids peak on the 23rd at 0 hours UTC. So keep that in mind. 20 an hour. That's, you know, that's what, 1 every 3 minutes. So yeah, it's, you know, for sure, if you haven't, you know, tried to observe a meteor shower, you should, because all the meteors that are associated with a shower seem to be coming from the same point in space. It's called a radiant, and so, you know, over the course of a few hours, if you're out there, you'll see probably several meteors that are sort of moving in the same direction, sort of look the same, you know, are moving at the same speed, have about the same colors, all of that, right? And you'll also see other meteors that are going at completely different angles, have completely different speeds, and maybe no color at all, you know, just white. So, so yeah, definitely get out if you haven't. It's best to observe meteor showers after your local time midnight. And of course, these meteor showers, hence the name Lyrids, are going to be appearing to be coming from the constellation of Lyra. So if you know where that is in the sky, you can sort of, look over there. They're not necessarily going to start in the constellation of Lyra. You'll see them all over the sky, but they'll all point back to a point in Lyra. So definitely take a look there. I'm going to check the chat really quick, make sure that I'm Apollo 6. I'm just reading what Tom said here. So demonstrate translunar injection and the command module's heat shield, phenomenon known as a pogo oscillation, damaged some of the Rocketdyne J2 engines in the second and third stages. Wow. Yeah. Interesting. Yeah. Well, these missions were definitely to try stuff out, and so yeah, things are going to go wrong, and you learn so much that way. So very, very cool. Yeah, well, they were in a hurry too. They were motivated. Yeah. All right, let's see here. So on the 25th, if you're in Western South America or New Zealand or Eastern Australia, you're going to see an occultation. You're going to see the moon pass in front of Saturn. So that's pretty cool. If you're in that part of the world at that time, it looks like it's happening around 14 hours UTC. So check that out for sure. That's given the opportunity to see a lunar occultation of a planet, you should definitely check that out. It is epic. It is really, really awesome. Yeah. I've seen Saturn occulted by the moon, and I think I've seen Venus. Pretty sure. I think I've seen at least those two. So let's see. Third quarter, or last quarter, as they call it here, is on the 26th of April at 22:18. Nice. Yeah, so here's another lunar feature, the so-called Curtis Cross. So it just it sort of depends on your angle, your solar angle, all of that, whether you see it or not. So also on the 28th, the moon is at apogee. It's furthest distance from the Earth this time around. So a little over 400,000 kilometers. It's kind of interesting because the distance between Io and Jupiter is about almost exactly the same as the distance between the Earth and the moon. So that sort of sets your scale a little bit. The closest large moon to Jupiter is about as far away from Jupiter as Moon is from the Earth. So hopefully that gives you a little bit of perspective there. So here, they go into a lot of details about various personalities and whatnot, right? Certain things that happened. HST was placed in orbit on April 25th. That's pretty cool. First radar bounced off the sun April 7th, 1959. Pretty interesting. Caroline Herschel discovered Comet Herschel in 1790 on April 18th. First photograph of the sun was taken on April 2nd, 1845. So wow, that's already gone and passed. And how long is that? That's let me grab my calculator again here. 2019 minus 1845. So that's 174 years ago. Wow. So that seems like a long time, but in the lifetime of a sun, yeah, that's nothing. So there's the Lyrids. So they're supposed to peak on what they're saying here, the night of April 22nd, April 23rd. So 20 meters an hour, that's adequate. You'll see some. Okay, so yeah, apparently the radiant lies between the keystone, which is a star pattern in Hercules, and the constellation of Lyra. Okay, but we're going to have a bright moon and mixed in with the Lyrids, so it's not going to be great viewing this year. Let's see what else we got here. Talking about the moon. Sun enters Aries on the 19th. I think we covered that. Oh, so here's just some some basic info about each of the planets. So their magnitude, their apparent size in arc seconds, how much is being lit up of the whole disk, how far away it is from distance from the Earth, I guess. Yeah. So Venus, nice and bright. Okay. Uranus, Neptune, Pluto, Jupiter to the south of the morning sky. Oh man, I gotta stop yawning. Let's see. First day of April, Venus rises at approximately 5:30 a.m. local time. Cool. Yeah. So now they just get into some great details, which I will just sort of leave you to read and ponder. But I think these are great. I think they do a fantastic job with these, and it is definitely, I would say, above and beyond what is necessary. Right? This is a lot of great info here. Boides, comets. So yeah, this guy is a 10th magnitude comet, fading fast, it says. So yeah, I think that's about it for this month. I didn't particularly see anything really that jumped out. Just sort of your regular old, relatively busy month. Moons, planets, clusters of stars. Yeah. Meteors. I like it. I like it. Okay. Well, like I said at the beginning here, I think I'm going to cut this a little bit short today so I can get out under the sky. It's likely to be clearing up pretty soon here. So I think I just need to be ready. There's a possibility that this clear sky is not gonna last. So I definitely want to take the opportunity. There's no wind, and there's no moon, and yeah, it's just humidity is non-existent. So it is definitely take any opportunity that I possibly can. So this is one of them. So yeah, I think I'm going to get out of here for now. Cut this a little bit short today, but we'll pick it up again, tomorrow, for sure, for sure. So cheers, everybody. Cheers, cheers. And with that, I'm going to get out of here for now. So have a great evening and a great day. Make sure to subscribe if you haven't already. Thumbs up if you so desire. Spread the word. I am looking for people just like you to come on in here and share the passion. That's what I'm doing. I just absolutely love astronomy and space and science, and I'm just voraciously curious, and so I've turned myself into a scientist, and I just eat it up. So yeah, I think that there are lots of people like that. We just sort of have to find each other, and we will, and we are. So, all right, everybody, take care. Peace, cheers, and all that. I'll do a live long and prosper, and I will see you on the spin just a little more than 23 hours from now. All right, take care, everybody. Bye.